Welcome to Azul Engineering Structural Design Team. My name is Kirana Maram. In the previous tutorial, that is tutorial part 1 and tutorial part 2 of basement plus ground plus 12 apartment building, we have seen that how to draw grid lines, including horizontal grid lines, and how to model this basement plus ground plus 12 apartment building, including how to draw column, how to draw beam, how to draw slab, how to draw shear wall, and finally how to draw lift. And we have also seen that how to assign slab loads and beam load, including well load. Today I will show you how to combine these horizontal and vertical loads, including dead load, live load, earthquake load, wind load, and that of lateral earth pressure load. After completing watching this video, we have mastered proto-structured software and structural designs of civil engineering projects. Don't forget that subscribe and share this channel to get more related videos all about civil engineering softwares, structural design, and construction technique. Let's start. Why we are going to combine load, or what is the benefit of combining load before we are going to analyze or design your building? We are going to combine loads together to expose the building, all the real loads that may be live load, dead load, lateral loads such as earthquake load, wind load, or lateral earth pressure, and to withstand for such load. To combine our loads, first it's better to go to analysis and building analysis. After that, before going to combine the load, we are going to enter to project parameters. Project parameters is due to select some building code that are used to design your building. In case our building is located in Ethiopia, Addis Ababa, so Ethiopian building code of standard is similar with that of Aero code, so it's better to use Aero code. For concrete design code, it's better to use Aero code 2. So I'm going to select Aero code 2 of European Union. So it's not necessary to select load code code for that of steel code because there is no steel. So even if it's better to select Aero code 3. For loading, it's better to select Aero code 1. Aero code 1 of European Union for the base code. For that of wind load, Aero code 1, part 4 is all about wind load. So it's better to select a code that is Aero code 1. Aero code 1 part 4, that is about wind action. So better to select. For earthquake, it's better to select Aero code 8. It is about all about earthquake. So Aero code 8, the base code, select the base one. So make it okay. After selecting your design code, it's better to go to. Okay, before this, it's better to insert our geotechnical report for foundation design. From the geotechnical report, our foundation bearing capacity of soil for foundation is 350 kilonewton per meter square. So it's better to select or insert your geotechnical report or the label stress of soil. So make it okay. After this, we have to enter to seismic parameters. Seismic parameters to modify the parameters all about earthquake. So here in the seismic parameter, it's better to edit this value. So ground acceleration in Ethiopia, Addis Ababa is located in zone 3. In Ethiopia, there are all about zone 5. So Ethiopia, Addis Ababa is located in zone 3. For zone 3, ground acceleration is 0.1. So you have to select 0.1. And that of ductility level, select a medium ductility class, So behavior factor is calculated by the software itself. The other data you have to insert here is that our soil parameter. So our soil bearing capacity is a soft rock. So you have to select class B from the 5 class. Class A is hard rock, and class B is all about soft rock. Class C is about clay and silt, and check the other that of class D and E from Japan building code of standard or that of European norm. So after this, it's better to make it okay after modifying some parameters of seismic. So make it okay. After that, it's better to go to wind and story load. So from this, we have to apply a wind load to all the stories. So it's better to modify the wind load or the wind calculator. Go to wind load calculator. After this, our project is located in Ethiopia, Addis Ababa. So the base wind speed for Addis Ababa is 22 meter per second, and that of wind pressure from Japan building code of standard is 1.5. So you have to change this parameter like this, and the terrain category. We have 4 terrain category. From this terrain category, 4 is selected for that of area around the city, because category 0 and category 1, 2 is all about. Category 0 is about the coastal area and such that. So it's better to select category 4, because category 4 is all about the city area. So make it okay. And our building is reinforced concrete. So apply. Okay. So after this, it's better to go to or select our wind or import our template to get a wind load in both X and Y, in both negative and positive direction. So protostructure by itself has a template for all design. That is, this is for a template for a pile cap, a template for a footing pad, and the last two are a template for a wind load. So it's better to select this one, make it open. After this, go to expand all the story. So uh, wind load index and Y. Okay, for example, for wind load index, you have to get uh, this is for story 2 or at the first floor level. So wind load index is 101, and that of in the negative X direction it is for similar for Y direction. So it's better to go to the other load combination, make it okay. After this, it's better to combine our load. So before this, it's better to go to load combination generator. So after this, define. Okay, this is for vertical loads. That is for dead and live load. Make it okay. So a state load. Okay, temperature load. Okay, we made that value. So create a load combination for both steel and concrete. So uh, okay, factor for dead load is 3.35 in case of Ethiopian building code of standard, and that of 1.5 for a live load. So after this, it's better to go to horizontal loads. For horizontal load, it's better to use first equivalent static load rather than that of modal or response spectrum. After the building fails in equivalent static load analysis, you have to change this to modal analysis or response spectrum analysis. First of all, it's better to use equivalent static load. So make it unclick on here, and it's better to apply 3% of direction loading. So create all possible restart this. Use a cracked section. Okay, for national load, make it okay to apply a wind load. So use cracked concrete. It's better to use a cracked concrete to be more safe. Use cracked section. Okay. So soil pressure, make it okay. Define a separate negative load case. Okay, it's good. So you have to select both vertical and horizontal loads. So it's better to make okay. After this, your load combination is done by the software itself like this. So it's better to okay. It's better to delete this load because it's not necessary. So you have to. It is dead load plus live load, and you have to add for serviceability. So serviceability, make it add. After this, make it service. Use the first load combination of service load, make it service. So you have to change the factor as 1 because it's for serviceability limit state. So all the load combination is performed like this. This is for lateral earth pressure in both direction, and this is for wind load. It's better to delete the national load, wind load in any direction. So in all direction, in the negative and the positive, and that of earthquake in all direction. So it's better to delete our load case, that of from your load case. You can delete this load because it's not necessary. Okay, sorry. This load. Okay, and the national load are not necessary in our combination, and the other are earthquake in any negative and positive direction, and that of lateral earth pressure, earthquake. Okay, so make it okay. Okay. In the next tutorial, we will see that all about building analysis and design. So subscribe our YouTube channel to get more updated video. It's better to stop here. Thank you.